Hello Year 10 Triple, this is 1.8 kinetic theory. We've looked at solids, liquids and gases and the particles within it. So now we're going to have a look at explaining how a thermometer works. Write the title. Draw the low temperature and hotter temperature thermometer. What I've done here is I have added 40 particles in total here into this thermometer, and as the temperature rises, the kinetic energy held by the liquid particles goes up, so they tend to move further apart, but the particles stay the same size. So effectively what you're doing with the hotter thermometer is just spacing out the same number of particles. They're the same size, they're just further apart. And as they have got further apart and they've got nowhere to move, the only place they can move is up the tube. And so it's a thermometer using kinetic theory. Next, the title is pressure, and we've got a couple of examples of pressure here. You're going to be working out the pressure of certain objects. Can you please write up everything that is here? You can pause the video for a second, but I'm going to move on. And the objects that we are going to work out their pressure are a bag of Yorkshire tea bags and a can of Coke. Now, in order to work out pressure, you need force divided by the area. To work out the weight force, you need their weight, and to work that out, you need their mass. More about that in a second. Now, to work out the area, you use these two equations here to work out the area of a rectangle and then of a circle. Anyway, I'm going to move on and I'm going to concentrate on this can of Coke. It's got a mass of 384 grams. Let's work out its weight force. So, to calculate the weight force, you convert the grams into kilograms, which is exactly what we've done there. And then you use this equation here. Weight is mass times gravity, where gravity on Earth is 10 newtons per kilogram. So the weight is the mass in kilograms, 0.38, multiplied by 10. That gives us a weight force pushing downwards of 3.84 newtons. What you then do is copy out this table. There's the can of Coke. We've worked out its area. That's the area calculation. That's the area answer in centimetres squared. That's its weight force in newtons. That's the pressure calculation right here. And to 2 dP, you've got the pressure. Now, even though the Yorkshire tea bags had more mass and therefore more weight force, because they are contained in a packaging that has a bigger surface area, you will find that the pressure here is lower. And then, if you've got time, you can use any example that you want. You can calculate the area. You can calculate the weight force, as long as you know its mass. You can do a pressure calculation, and you can give us an answer as well. Many people will think that the pressure of a tank will be much greater than the pressure exerted by a ballerina. But the problem is this: even though the ballerina has a lot less mass and a lot less weight force, she does have an incredibly small surface area and her tippy toe. So what I'd like you to do is write out a letter using all this information here and proving using equations and number values and answers, prove that a ballerina exerts more pressure on the ground than a tank. It's almost like a persuasive letter. If you were to take a bottle and put lots of holes in it near the base and then fill it with water, what would happen is the water would spurt out with the same amount of force. It's because pressure in a liquid acts equally in all directions. Please write that down as a title and then write that down underneath. If you get the chance to do the experiment, have a go or look on the web and you'll see it's correct. Hydraulic machines, this needs to be written down. Hydraulic machines use liquids moving in a confined space under pressure. These include car jacks, door spacers, door closers, tipper trucks, that type of thing. Write this out as well. Have a read through. Particles in liquids are close together. They're virtually incompressible. You can't squeeze them down anymore. So the pressure in a liquid is transmitted equally in all directions. So a force exerted at one point on a liquid will be transmitted to all other points in the liquid. Really important, that. So this handout here that I can't give you at the moment, but you can draw it if you want, shows a hydraulic car jack, and it can be used to lift a car. When the handle is pressed downwards, there's the effort, 30 newtons, oil is forced along here, through here, and it pushes upwards with such force that it can lift the car up. It's called a force multiplier. Now I'd like you to have a go at these calculations here. The answers are next. Let's just have a look at them. Calculate the pressure. Pressure is force divided by area. That is 30 divided by 0.2, and that gives us a pressure on that narrow cylinder of 150 newtons per meter squared. But oil is a liquid, so that pressure is transmitted equally. So on B, it is also 150 newtons per meter squared of pressure. But that means that the load force, the pushing up force, is going to be greater. Force, F, is P times A. The pressure is 150 multiplied by the area, 1.6, and that gives us a load force of 240 newtons. It's a force multiplier. You put in 30 newtons of effort here, and the load force that came out was a whopping 240 newtons. You've multiplied the forces by 8. Write out this, and that is the end of this double lesson. Well done today.